Analyst, Maricopa Association of Governments, Arizona, United States, for sharing her valuable insights on the topic Freight Congestion and Framework, Understanding Truck Traffic Through Socio-Spatial Structure. Now I request Sri Anish Kini, scientist, to deliver the welcome address.
Thank you. KSCSTE-NATPAC has initiated the TransPedia Talk Series, a technical discussion platform aimed at fostering research for mutual benefits by sharing knowledge on diverse topics ranging from cutting-edge technologies to sustainable solutions. This initiative aspires to create opportunities for young researchers worldwide to connect and collaborate, shaping the future of research and development in transportation. The inaugural session of the series was held on August 24th, 2023, with over 200 participants from prestigious institutions and organizations. The event began with an inaugural address by Professor Dr. Tom V. Matthew, Chairman of the Research Council, KSCSTE-NATPAC, and Professor at IIT Bombay. Over the past year and a half, around 16 sessions have been successfully conducted, covering a wide range of topics in transportation engineering. Today marks the 17th talk in the series, presented by Dr. Sarvani Duvuri, Transport Analyst, Maricopa Association of Governments, Arizona, United States. It's an honor and privilege to welcome our esteemed speaker, who will share her expertise on understanding truck traffic through socio-spatial structure. Following the presentation, there will be a question and answer session offering you the opportunity to engage directly with Dr. Sarvani. We encourage your active participation in this meaningful exchange of ideas. Thank you once again for joining us. Please join me in extending a warm welcome to Dr. Sarvani Duvuri as we look forward to her valuable insights. Thank you.
Thank you very much. It is an honor to present here. Let me actually share my video presentation.
Okay, ma'am, just again, ma'am, we'll just give a brief intro of you and then we'll start off.
Yes, I have that in my slide actually. So good morning, everyone. I'm Sarvani Duvuri. This is my presentation about my dissertation. To give a very brief background about what my education and work experience is, I completed my BTech in Civil Engineering from Geetham University, that is located in Andhra Pradesh. And then in 2018, I moved to the US to pursue my master's. And after my first semester, I joined PhD. So it was an integrated program. So, and I finished my master's in 2020, and in 2021 mid-year, I finished my PhD. I worked as a postdoctoral researcher for a year. And then after that, I transitioned to the regional planning organization in Arizona, which is known as the Maricopa Association of Governments. And over the course of my master's and PhD, I had privilege and also opportunity to work on various projects related to simulation, travel time modeling, and many like safety, and also learn more about transportation. And I'm very thankful for that, and which is very relevant to what I'm working. I will mention a few more snippets as I present. This is a very brief overview of my presentation. I'll go through some background and some research questions and objectives that were derived from my curiosity when I discussed with my professor. And I do want to mention one thing. I was mentored by Dr. Srinivas Pulgurta, and that has been there from master's and also PhD, and which also escalated to a postdoctoral level. And I'm very thankful for him to provide this opportunity, and all the research and experience that I got, I owe it to him. And coming back to the presentation overview, I'll go through the background, research questions, study area, data, and methodology, followed by the results, and a little bit about the conclusions and the future research. And at the end, I'll go to the questions. I'll try to keep this very brief. I know the number of slides are very large in number, but I'll try to go a little faster so that we'll have some more time to discuss and maybe interact more. And a few disclaimers I do want to mention is in the title, I didn't mention specifically about on-network and off-network, but I do want to mention the on-network means the roadway characteristics, which is number of lanes, functional class, and speed limit, etc. And the off-network refers to the nearby land use and also what kind of zoning it is, and also the demographic characteristics. And I do want to mention, I just used a generalized word truck in this, but I do want to mention that the data that we got is for the freight truck, and that is that transports at least 20,000 pounds or more, which is like the largest trucks that we that are generally found here, not the Amazon trucks or any smaller trucks that are used. Coming to the background, we know that trucking contributes to majority of the freight tonnage in general because of the on-road transportation and the contribution to the last mile deliveries. And obviously in the last few years, we have seen a lot of demand increasing in the online shopping and also the groceries and many other physical good deliveries. And especially in the COVID time, we have seen nearly 8% growth overall post-pandemic. And I remember even during the pandemic, people were scared to even go to restaurants and eat, and even relied everything on just the online shopping and everything. And even from some of the reports that we get in the American Trucking Association and Research Institute, they projected so much like growth in freight by 2031. And also like due to this, one of the major challenges is the congestion due to that is incurred. Obviously, like the demand is never projected, and there is always like constant road or the highway system. And of course, increase in freight is also increase in trucks and also increase in warehousing and also distribution centers. The reason I mentioned the warehousing and distribution centers is the type of truck that I mentioned, mainly the destination is to the warehouse or the distribution centers. So I'm more interested in seeing how this pattern is affected, or how the large trucks are affected due to congestion. And some of the statistics also show that it is almost $6,500 per truck annually, and there are many trucks that are currently in use. And obviously, like when we see trucks with the passenger cars, they vary very significantly. For example, if I'm driving, I would like to keep some safe distance, obviously creating more space in the road, and there are many psychological aspects to it, and which also addresses the fact that link level travel times that we get from cars are not equal to trucks, or the characteristics vary. And one of the major sources that we use here for the travel times is the probe data. And not only just the academia, but also federal, state, and local agency use the travel time data to assess the performance. And I was more curious to see how on-network and off-network characteristics improve, like, or influence the freight demand and their travel performance. So my dissertation focused on understanding this particular relationship with the surrounding characteristics, and also how these variables can be used to estimate the travel time. Coming to the research question, travel time reliability and performance is obviously used a lot in many research, and also in very wide range of practical application. One good example I can think of is the place where I work. We generate a report called system performance report. So where we use all the travel time reliability and come up with where the freeway bottlenecks are there. And it's really important for us to see where the resources can be allocated. And obviously, if we see travel time reliability, the passenger car and mixed stream data is typically captured because of the data where it comes from. Generally, it comes from the navigation apps. But in case of regional travel demand models, we also use land use, socioeconomic, and demographic characteristics for planning. But why truck traffic is not exclusively considered for that? And I do want to mention one more thing. In case of regional travel demand models, typically when you want to plan for estimating the travel time, there is a huge lot of effort that goes into it. For example, collecting the household travel surveys or commercial surveys. and then inputting that model into understanding how the interaction is with the land use and socioeconomic. But that is fairly like an expensive part of the project. My intention was to see if we have such abundance of abundant probe data that we have availability, why not use that for estimating a travel time of trucks, and then even also understand what the interaction is. Hence, my research question was to incorporate these independent variables to estimate the truck travel time on a road link or also corridor. And one more thing I was more interested is to see how it is applicable at the regional level. And even there was some literature review that we conducted, and I saw that there was a limited research on travel time estimation exclusively using the on-network and off-network characteristics as the independent variables. So my objectives are as follows. And first is to examine the correlation between various truck travel time performance measures. This was to ensure how we are measuring the truck travel time performance in general. And the second one is to examine the correlation between the selected performance measures with on and off network characteristics, which is to understand what variables are, how the variables are, and potentially use that for modeling. And the third one is to develop the models. And I won't go through the detailed literature review, but I wanted to emphasize a few things. First is the passenger car equivalency estimation methods are very dominant in the field of transportation. But in that case, I personally felt it was hard to capture the variability in travel times, and some of the aspects such as temporal variations and everything are not accounted. And even the measures proposed for freight performance account for multiple modes. It is mainly due to the data that we get, and in lack of data that is exclusively related to the freight. And even in the field of travel time reliability that focuses on the passenger cars or the mixed stream data, as I mentioned. And the next limitation that we found was significance of truck travel at the regional area. It is easy, it might be when I was doing this dissertation, it was hard to find data for multiple samples in a single road. So, and even the data was booming. So even considering the regional wide analysis, obviously there is a limitation of availability of data. And the next one is to trucking is influenced by the surrounding area characteristics, which also iterates to the main intention behind my research is how these on and off network characteristics have effect on the travel time. And coming to the study area, this particular map shows the state of North Carolina. Here we have a divisions called counties. And in North Carolina, there are nearly 100 counties, and I selected 3 particular counties. In the middle one is called the Mecklenburg County, where I used to live. And the left one is the Buncombe County, and the right one is the Wake County. The reason I selected these 3 counties was to include multiple diverse characteristics. The first one, first criteria for me was to understand what data is available and even what kind of area it is. So here you can see Mecklenburg and Wake County are urban regions, and the Buncombe County is the rural region. And it is located in a mountainous region as well. And even though it is from mountainous region, many of the freeways have significant freight volumes, and we had a good amount of data that we wanted to account this for modeling. And coming to the data collection, we relied on the National Performance Management Research Dataset. It was newly available by the time I was starting my research because they had data from 2017. And one of the things I was more interested is to explore exclusively truck data. This data had a categorization of passenger cars and trucks separately, and they had a bunch of variables that we also got to explore. First is the road link level travel time data, as I mentioned, and it had speed and also timestamp, and also the data density. Data density also represent how many reporting vehicles we have, and of course the data that we get is not accounting the entire samples, because it depends on the contract that they have with particular companies that they allow to share their data. And the reason the timestamp is also very important is the link level travel times that we get. They have start point and end point that are located that are mapped in their system. And when a vehicle enters the start point and exits the end point, that's when the start and end timestamps recorded, and from that the travel times and speeds are calculated. So it was a good check for us to compute speeds and travel times on our own. And the next is the on-network variables that we get from the NPM-RDS dataset. And the off-network variables are the ones that I acquired from multiple sources. We had parcel level land use, which was from open source platform. Of course, the data was not completely clean, and we had to work on a lot of cleaning process just to make sure that the data is usable. And the next one is the demographic characteristics. We had two options. First is look at the census estimates, and then other is the transportation planning models. And I chose the TAZ level, traffic analysis zone level for from the transportation model, because it's updated every 5 years, and TAZ units are typically lesser in area compared to census block, which makes the data more accurate, and also we can understand more diverse demographic patterns. And coming to the data processing, I considered 4 times of the day and 2 days of the week, but that is weekday and weekend. And then I considered morning peak hour, afternoon peak hour, evening peak hour, and nighttime hour. And of course, all the outliers were removed and make sure that the data was clean. And even some of the links with very small distance or length were excluded, because there was a potential of many outliers in the data set. And a total of 501 road links were used, out of which majority was in Mecklenburg County and followed by the Wake County, and a few were in Buncombe County. And using this travel time, I computed various descriptive measures, percentiles, reliability measures, and to see how the relationships are. Just to show like how many links or how the roads are distributed, you can see there are multiple freeways and highways in Mecklenburg, and Buncombe there are 2 major highways, and similar in Wake there are 3 major highways. Coming to the data processing, I used the following measures. These are pretty standard, multiple travel time reliability measures, and some of them have indexes as well, which does not have any units. And coming to the data processing related to the on-network characteristics, from the probe data, the on-network characteristics were extracted like on a direct way. Coming to the off-network characteristics, I used parcel level information and developed 18 categories. The reason that we compressed that to 18 categories was some of the data, some of the counties data that we get. For example, in case of Mecklenburg County, there may be some 100 categories of the raw data set in land use. But in case of Buncombe, there were more than 170 categories. So in order to make sure everything is consistent, each category was analyzed, and then make sure that we divided all the parcels into 18 categories for all the counties. That was the major part of the land use processing. And also we computed the percent of developed area. For example, in case of agricultural area, it may not be considered as developed because there won't be any freight expected there. Or similar, if you can see in case of unknown or vacant land use. So even that we cannot account for freight. So in that, so some of the formula that we used, we obtained. We computed even the percent of developed area within a buffer. So as you can see in like effect of land use on a road link, it's impossible to, or if it's very difficult to capture if you're considering the whole area or the whole land use in the county. So we used a buffer analysis. We simply used the link and created a buffer around the road link and computed whatever the demographic and also the land use characteristics, and then created or computed the variables that we wanted. And one of the things always is there is a question like how much buffer we need to consider, and it can be more or less. So we considered 0.25 mile, 0.5 mile, and 1 mile buffer. And of course, all the models were also developed based on this and to understand it thoroughly. And as you can see in the images, you can see those are diagrams that I generated using 1 mile buffer. And in case of demographic characteristics, I used population, number of household units, population and employment densities. And this I obtained from the regional travel demand model. And these are the land use variables, the 18 categories that I mentioned earlier. I won't go through, it's just a very brief overview. And coming to the data processing, as you can see in each TAZ, there is a population and also population density. But if we are considering a particular buffer, it's difficult to capture. For example, if the TAZ is not completely shown here, for example, this TAZ is completely captured, but in this case, it's only partially captured. So in order to account for all that, we computed weighted population and also like the revised population density and also the revised household values and revised employment and population density using this equation. Obviously, it is considering the area, part of area, and dividing it to the total area. And the one that I mentioned about the percent of developed area, there is a definition by the Environmental Protection Agency, where developed area represents the area of development where people live, work, and play. So in this particular percent of developed area, I just subtracted all the undeveloped or which cannot be used in this particular categories. So which is the agriculture, resource, and unknown or vacant. So resource land use is nothing but if it has any wetlands, creeks, or any water bodies that cannot be used for the land use calculation, and divided by area of buffer, of course. Coming to the understanding the relationship between the travel time performance measures and within their performance measures and also the on and off network characteristics, I used the Pearson correlation analysis, and we used the selected performance measures from the whatever we did in the travel time reliability measures correlation, and then use that with the on and off network characteristics. In this way, we are understanding what the performance of the truck how it is associated with on and off network in terms of correlation. And obviously this analysis was done by time of the day and also the day of the week, and we considered all the coefficients that are only at 90% confidence, that are significant at least at a 90% confidence level. And coming to the truck travel time estimation models, which is the final step of my step in the methodology, which we use the generalized estimating equations that were which were used because the applicability when the data is not normally distributed. And we used linear gamma log link, Poisson log linear, and negative binomial link models to test out which one is most suitable. And the goodness of it was assessed using QIC, quasi likelihood, and QICC values. And in this particular modeling, we used average travel time per mile. The reason that we used is the link level, the length of the road or the link varies depending on the data and obviously the length of the freeway and everything. So standardizing it per mile is easier, and it makes a lot of sense to compute and also to account for varying mile length of the link. And of course, variables like population, household estimates, and even population density and employment density, they are represented in thousands in order to reduce the coefficients values. And even AADT was transformed into ln of AADT. The travel times are generally, for example, 1 minute per mile. It doesn't make sense to use some 1,000 households or 5,000 households. Similar with the AADT. And we use 75% of the data for modeling and 25% for validation. And coming to the estimation, travel time estimation models in the final step, obviously, like there are multiple things that we wanted to capture, like which approach to capture the off-network characteristics. Of course, we have 3 buffer lengths, but there was also one idea. What if the length of the vicinity, the effect of the length of the vicinity changes as we move away? That was the reason we also wanted to explore an option of spatial weights. And also the next thing we wanted to see is which models are suitable for truck travel time estimation. So in case of spatial weights, we consider three types of buffer, 3 types of decaying function. First is 1/j, which is inversely proportional, and the one is 1 by j square, and the third one is 1 by j cube. So in this particular, you can see as the power of the denominator increases, the effect of the nearby characteristics are emphasized more. I'll show in a minute. And just to close the loop on the approach to capture on off network characteristics, we considered all the all variables for all buffer width, variables from each buffer width, and also the spatial widths. And yes, the influence of power to the 3 that I was talking about, as you can see, the spatial weights were computed based on the decay function. And as you can see in this particular plot, in 1 by d, it's fairly like 57% is weight of the weightage is given to the 0.25 mile buffer. But in the case of 1 by d square, this particular percentage increases, and it's the same with the 1 by d cube as well. So as the distance increases, the effect of the 1 mile buffer or 0.5 to 1 mile buffer is almost minimal in case of 1 by d cube, as you can see. And I think it's a lot like that I spoke about the travel time estimation models. I think this will give a better picture of what exactly is going on. So as you can see, we have all the records, that is 501 links we have used for like modeling and validation. And we have modeling. There are 2 types of aspects that we are considering. Along with, there was one more aspect where we use all the data. And we used buffer width, which is 0.25 mile, 0.5 mile, and 1 mile. And the next one is the spatial weight. And of course, all the GE models were explored in this. And one of the things that is important to even understand is there are multiple speed limits in the data set. And at the same time, there are multiple counties as we considered. So there was one more idea to see what if the data is only if we segregate based on speed limit or county may yield some better results. So the data was also clustered based on speed limit and county to understand the models or which approach is better. And coming to the model validation, we use three variables, which is the mean percentage error, mean absolute percentage error, RMSE, root mean square error, where the first 2 are expressed in terms of percentages, and the last one is expressed in terms of travel time, which is minutes per mile. And coming to the results, the first step, as I mentioned, is to understand the relationship between various travel time performance measures. So as I mentioned, we have Pearson correlation table, and we have 8 tables because 4 times of the day and 2 days of the week, which is weekday and weekend. And instead of seeing each correlation of how it is correlated, is it high correlated or moderate or low, we have 8 separate tables. So in order to compress all that into one particular table, I allocated scores, where each scoring is dependent on what is the correlation coefficient. And the maximum score is 24, as you can see, because 3 is the maximum score, and there are 8 tables. So based on that, percentages were computed and they were represented. This is one sample correlation table. As you can see, the minimum, maximum, average travel time, variance, standard deviation, all the percentiles, all the reliability measures that I mentioned. As you can see, it's very hard to interpret, especially 8 tables, and to derive something from this. So we used a percentage and also like a scoring mechanism to understand how these patterns are reflecting. One of the things that we understood from this is there is a high correlation among the descriptive travel time measures, which is the minimum, average, and all the percentiles. And of course, the variance and standard deviation are correlated positively with the minimum and percentile measures. And this depends on how the travel time performance are varying. And we initially expected skew width measures may have some patterns, but I did not see any particular correlation trends, and it had mixed trends. And based on one of the things that while the correlation analysis was conducted, we also based some on the past research as well. Because, for example, as I mentioned, we have the system performance report that we every time like use in my current workplace. So there we use the buffer time index and also average travel time. And many researchers also suggest use of planning time index or travel time index to measure the reliability. So in relating to the correlation and also some trends from the correlation analysis and also the past research, we concluded that average travel time, planning time index, travel time index, and buffer time index were used can be used as a performance measures. So the next step was to understand the correlation between the truck travel time, these performance measures that I mentioned, and understand their correlation with the on-network characteristics. As you can see, there are a number of lanes, functional class, and also there are multiple like speed limit and different speed and many things. And this, the other part of this correlation analysis was to see the performance or correlation of the truck travel time performance measures with the land use characteristics, where land use characteristics here are mentioned, are represented in square miles, and there is a variable which is indicated at the end, which is a percentage, which is the percent of developed area. So coming to the brief results, as you can see, there are like low positive correlation with the number of lanes that being less than 6. So this more represents the arterial section, and low negative correlation with greater than 8 lanes, which means more likely these are like the interstates that are present in some low population density areas where if there is like 8 lanes or where typically less traffic is expected. So it is pretty expected that it is the case, and in case of interstates and rural area, they have a negative correlation with the performance measures, which makes a lot of sense. The performance is high in those kind of areas, whereas principal arterials and urban area type have a positive correlation, which means that as the values tend to increase in areas such as arterials and also urban area, which is accounting for the high traffic. And of course, there is no particular trends in case of functional class was were observed. For example, in case of arterials and interstates, it was pretty straightforward, but it is hard to interpret for all the area types. And considering in case of like land uses, we can see there is a positive correlation with college, government, commercial, office, and industrial land uses, which makes a lot of sense because even when I was studying at my university in the North Carolina, we used to see a lot of truck traffic near the university, meaning there is these all are high traffic areas, in especially commercial or industrial, and considerably negative correlation with the resource land use, vacant, unknown land uses, which was what we expected, and that's what the data delivered. And even the average travel time was positive, like had a positive correlation with population and household units, which is pretty straightforward. And coming to the travel time estimation models, I wanted to give a very brief overview of how, like, what the models are, how many links are used for modeling, and how many links are used for validation. As you can see, they are summarized in all variables from all buffer widths. And as you can see, the other is the variables from each buffer width and also the spatial weights. And the next segregation was based on speed limit and also county based, which is based on the area that we use. So this is a very brief overview, and don't be confused with the number of records. So 501 links were used, but 4008 records is because of the time of the day and day of the week. So 501 into 8 is 4008. So that was the whole reason for representing all this. And I use the QIC and QICC values as I mentioned. I won't go into very detail about this. And this was for buffer width and the spatial weights, the first set of categorization that I showed. And this is based on this is for the data validation. This is for the same set of the QIC and QICC values that I showed earlier. And as you can see here, in general, on a high level overview, you can see that the 0.5 mile buffer performs better. 0.25 miles, sorry. And coming to the model results, I won't go through each and every point, but I do want to mention that linear model with and without intercept and gamma log link models were developed because of I mean, as I mentioned earlier, these were found to be applicable and based on the results. And coming to like some of the land uses, we can see light commercial, retail, heavy industrial, and transportation land uses had an increasing effect on the average travel time per mile, which is what we expected because of how heavy the freight traffic or how the trips are attracted towards these kind of land uses. And however, some of the correlation results that we got, for example, in case of college, it showed that it had a decreasing influence when we looked into the model overall. Similarly, in case of population, you can see population and employment density, they have an increasing influence. And these, for what my understanding was based on this, you can see that it's not just the land use that is attracting the trips, but also if there is an area which is highly dense in terms of like population and also employment density, we can see that there will be some distribution centers or some opportunities for the trucks or the chains to open nearby, and then that's where the freight is all obviously like getting attracted to. And coming to the buffer weights and spatial weights, you can see that afternoon peak hour had the best, has a decreasing effect, which is accounting for the off peak, and similarly for but for the morning peak hour and evening peak hour, they have an increasing effect. Similarly, I think it's almost like replicating the previous ones, which is the office, light industrial have a consistent increasing effect. And coming to the QIC and QICC, there were similar trends overall and modeled, but in terms of buffer and spatial weights, we observed that the models from the buffer width performed marginally better. So there was no need of accounting for, so waiting for spatial decaying function and such. So buffer width found to be perform better. And coming to this models based on speed limit, we segregated the data into 3 categories, which is less than or equal to 50 miles per hour, and greater than 50, and less than 60, and greater than 60. This classification was used on how the posted speed limits were, or how the speed limits were posted based on in various areas. Typically, in case of greater than 60 or 65 is where there are like for sure they are interstates, and from 50 to 60 they are state highways, and many local arterials also experience these and rural highways. So that's the reason we use this kind of segregation. And as you can see, there were consistent results such as office and retail land uses, and also the percent of developed area have an influence on the average travel time per mile. And in case of like greater than 50 to 60 miles per hour, we can see that some of the areas such as college, institution, agriculture have increasing influence on the average travel time per mile. And coming to the greater than 60, you can see office and employment density. So from what the whole results from based on speed limit, we understood that the patterns does not seem to be very conclusive or very strongly aligning with the past research, mainly because of limited data sets. I'll be talking about it more in the conclusion section. And coming to the county-based results, we segregated the data, or we separated the data for Mecklenburg, Buncombe, and Wake County. So as you can see in the first look itself, Mecklenburg has better sample size, and followed by Wake County and the Buncombe, and the last comes the Buncombe County. So even here you can see there are results were. However, even despite of the lower sample sizes and even consistent sample sizes, we can see there are typical patterns that were observed in all the 3. For example, in case of Mecklenburg, it was office, retail, and unknown land uses have increasing effect, and also number of household units accounting to the higher demographic concentration. Similarly, single family residential, agriculture, and employment density has a decreasing influence. And coming to the Buncombe County, we can see that college, government, and medical land uses have increasing influence, and industrial have a decreasing influence. And coming to the Wake County, we saw one more interesting thing was some of the linear models had negative intercepts, which may not be too ideal to interpret or justify in any sense, because of how, for example, if we have every value 0, the whole travel time per mile ends up being negative if based on all the substitutions of the values. And in case of Wake County, we can see commercial land uses, household units have an increasing influence, and some of the other demographics such as population have a decreasing influence. Coming to the travel time estimation models for the speed limit and county calculation, we can see that they have lower QIC and QICC values for 0.25 mile buffer, which were similar to the one we saw for where all the data was considered at a time. And coming to the model validation results, we saw that there were lower error for 0.25 mile buffer width. So from this, even though some of the model results were inconsistent, or there were multiple results that were showing, it was always safe to say from the beginning itself that 0.25 mile buffer was found to be more effective or appropriate to capture the truck travel time performance characteristics. And coming to the conclusion, as I mentioned earlier in the introduction, I do want to emphasize that trucks are susceptible to congestion and additional delays. And due to these delays, there are additional costs that are associated with it, especially when we consider the freight transportation. And results from the correlation analysis, we know that it indicates that average travel time, planning time index, buffer time index, and travel time index were suitable for the truck travel time performance measures, and there were consistent patterns with the on and off network characteristics. And on a high level, we can see that urban areas and roads with high traffic volumes or number of through lanes have a significant positive correlation with the truck travel time performance measures, which means some of the areas with high traffic volumes, or which is obviously representative of the urban areas, have higher values of average travel time, meaning more congestion. And coming to the land uses, we have like agriculture, college, light commercial, light industrial, institutional, single family, and other land uses that had correlation associated positively. And one of the things here I do want to point out that even though agriculture was not considered as part of developed area, my belief was that, as I showed in the initial slides, the data from the NPM-RDS data also includes truck trailers which have tractors associated with it. So my understanding is there are some trips that were made to agriculture, even those trips are available in this particular data set. So that's the reason there were many associations observed in case of agriculture in many models, for example, in the speed limit model that we saw, or even in the overall correlation analysis that we saw. And coming to the office, light industrial, and multifamily residential land uses, they have an increasing influence on the average travel time per mile. This was based on the modeling result. And of course, population and employment density have an increasing influence, which also accounts for how the activities are nearby and how the developments are going nearby. And from the model results, as I mentioned earlier, 0.25 miles was found to be suitable, and the initial thought process behind the spatial weights was found not too appropriate. I would not, if I were, if given a chance, I would not disregard it too much, because all this interpretation and the modeling was based on some data set that was developed that I would say it was fairly new to explore. And NPM-RDS data was out, we got the access from 2017, and the analysis was done for 2019. So it was fairly new data. And I'm assuming now it is 2024. If we have access to some of the data sets in 2024, and I know even post-COVID, North Carolina has seen a lot of increase in the residential and even the employment opportunities. So I feel that can be like explored in the if someone wants to explore that can be explored significantly. And I know some of the various migration patterns are also changing in terms of North Carolina and even the demographics. So I think that would be a good segue. And coming to the speed limit based classification, the reason that we were interested to understand is based on the road facility. It also represents what kind of it also has the consistent range of travel times if we are segregating the data based on the speed limit specifically. And there was obviously improvements in terms of goodness of fit than unclassified data, but we didn't get the results that we expected. And my understanding was based on the lower sample size, especially considering like low speed links or higher speed links. And coming to the county based classification, it was found to work better for developing and estimating truck travel time models, because one of the things that is accounting for is the local variations. For example, if I consider Mecklenburg County and Buncombe County, they are two completely different counties. because Buncombe County, even the road geometries, they have super high grades, and also the curvatures are very significantly different than what they are in Mecklenburg County. So even people are that psychological thing behind how people drive or how people even dwell in those areas are very different. So county-based classification, we found it works better for developing and estimating the truck travel time models. And coming to the truck travel time estimation accuracy was also better in case of county-based classification. And one of the things I do want to mention as I go back to the NPM RTS data is we had so many more interstate or even freeway links in the overall study area, but not all roads had data. And estimation using available road characteristics, land use was done in this particular research. So having more data is also very resourceful. And coming to the scope of future research, as we can see, the plausible application of spatial models and supervised learning approaches is also one thing to explore in the future. And the reason that was not explored this time was because of the lack of the samples. As you can see, there are just 500 links. And even with a limited, there were already too many steps, and understanding that particular pattern, it itself had a lot of interpretations and also a lot of learning that I did. And coming to the average travel time per mile, which was used as the dependent variable in this case, which is the estimation of the average value. But there are many there are many branches of this particular research that can be done, which is the estimation of planning time, which is either 95th percentile, or sometimes people use the 90th percentile as well in order to exclude the outliers, and which also helps account for recurring and non-recurring congestion. And the other is also to estimate performance of the trucks and compute the selected reliability measures. Not only just planning time, we can also use something like a buffer time, which can also be a good understanding of how much buffer is needed. And the next one I wanted to explore is what if I want to compute only Mecklenburg County or estimate only for Mecklenburg County, but also I can segregate based on speed limits. But given only 500 links, that too overall in all the 3 counties, it was very difficult to understand, segregate, conduct a two-level clustering or stratification because of the lack of samples. But that can be a very good area to explore in the future once the data is available for all the links, or majority of the links at least. Thank you. I think that would conclude my presentation.
That was a nice presentation. Thank you, ma'am. Now the forum is open for discussion.
I can stop sharing and I can reshare if needed.
Sarvani, it was a good presentation. This is Anish from NATPAC. Yeah, so I just wanted to understand whether these models were direction-wise, like for a freeway, it would be prudent to do it for a directional analysis. So was that considered?
Yes, we considered the direction separately because the way we get the data, probe data, as I mentioned earlier, the vehicle enters the start point and exits the end point. So in that way, we are just accounting for only one direction. So that was one of the things that was considered initially.
And all the links were of freeway links, or did it have any urban sort of characteristics as well?
It also had arterials, so they have different definitions, but I do want to mention that they also had signalized intersections or the arterials. But the way they are coded is, in case of freeway, they are captured from one entry ramp to the exit ramp as one link. In case of arterials, it is like one upstream and one downstream link between the two intersections. So even the delay or the stop delay is accounted for. So both type of roads are considered in that. And the reason that we didn't consider the segregation based on functional class is the questionable sample sizes. I know most of the links that I showed in the maps were freeway links, so very few were arterial, so we didn't consider based on the functional classification and then model based on that.
Okay, okay.
Thank you.
Dr. Savani, Vasudevan here.
Yes.
I have a few questions. Did you do any sensitivity kind of analysis with various land use for different three counties? Like how the travel time variations are happening about based on various land use?
I actually did not do that because some of the times I realized there are not many land uses that were captured in each buffer, and that can be like I would have shown one image where sometimes it is like there's only one land use or hardly two land uses. So I found it was very challenging to have a sensitivity analysis. Maybe I should have at least like subsetted the data and then considered. So that can be explored in the future, definitely. That's a very good question.
Okay, and one more question, how this travel time performance functions is actually interpreting based on this land use. For example, if the travel time performances for the educational purpose or the land use which is having commercial or educational institutions, how that particular performance functions will interpret in that case.
So
Whether the travel time is higher in those areas like that. Or what is
so
the
the
interpretation?
yes. So the model interpretation, the way we see it is, for example, if there is an increase in 1 square mile of college area or any educational land use, how much is the increase in? For example, if the coefficient is 1.0, so one increase in travel time by 1 minute per mile is accounted to increase in land. If there is an increase in, let's say, 1 square mile of the college land use, that was the whole idea behind that, because I considered the land use in terms of square miles, and of course, it depends on it is associated with the minutes per minute. So that I does that answer your question, or am I like interpreting
No,
it
actually
wrong?
that is fine. But actually, I would like to ask that what is actually the result from your analysis, whether your colleges or whether this institute from your study has influence on this particular travel time functions or not?
I'm
Because
sorry, I
the
didn't
travel,
understand. Sorry. Can you repeat that? Sorry.
yeah, actually, whether this travel time performance functions influences based on this particular institutions, like. In your study, in your county, for example, whether this land use of education institutions has influence on travel time, because the travel time, whether this travel time of truck is higher in those areas, or how to address these challenges from this model.
Yes, I think like I feel like there are already some developments that are happening. And I think one more thing I wanted to mention before, like in the presentation, but somehow missed, is the way these land uses are, they are updated every year. So even if there is an increase in land use, we can obviously capture in the GIS or the processing that we are using, because they are always added as one more layer to it. So I think the way I would see is to just capture the buffer. If someone has to estimate, for example, if they want to capture for 2020 year or 29, which is just right after, assuming that the COVID didn't happen. So they can capture the buffer and see what kind of area is nearby. Let's say, for example, area within the buffer is always same. Even if the educational land use, there is a vacant land near the educational land use, let's say. On 2020, it may have transferred, the unknown land use or the vacant land use reduces and the education land use increases. So this model, what it will do is estimate based on this increased area or based on this particular area, and develop and gives the travel time that can be expected. Since we already know that there is a positive influence on, like the coefficient is positive, meaning the average travel time per mile increases as the area increases, we can better capture these particular aspects, because we know for sure that the area within buffer is always constant. It's just the categories that change.
Okay, understood.
Okay.
Dr. Savani, this is Praveen from NATPAC. I'd like to know whether while doing the data collection and all, like the type of parcel or the type of goods were noted, like whether for different trucks it will have a different travel time, and was it considered as a factor or something? What is the type of good it is transferring, like it's a perishable or non-perishable or something?
Yes, so that was one challenge we have. So so the data that we get is typically under the contract of the State Department of Transportation or whatever, like in general, the way we get. Most of the times the companies do not disclose. Even they try to keep it very minimal in terms of disclosing all the information, and of course due to the privacy reasons. But I'm assuming there should be no, even if there are some perishable goods, I feel the trucks, those are not long distance travel. But some of the trucks are used for long distance travel. Some come from Canada or even some come from Mexico. So it's hard to determine based on that, but I know for sure that they carry greater than 20,000 tons. But that was a main limitation in any kind of data we get from third party, that we don't know the whole picture.
Okay, I have just one more question. Like, what was the range of standard deviation or something? Like your models were predicting the travel times in a good manner, but what was the standard deviation like for different buffer zones?
I think the standard deviation in general, we did not see any weird patterns. Let me just refer to some of the values. Okay.
So was it comparable to your typical land use characteristics and all?
Yes, it was comparable, and I mean, I personally did not see any weird or any unexplainable patterns in general, but I can share my screen actually. This is from the paper that we published. So as you can see, in terms of like, let's say if we consider weekday morning peaker, the average travel time per mile. The mean, maximum, and the standard deviation was not as we expected. The values were pretty low for what I was expecting, or because I was little nervous before exploring the data, I would be honest. But the data was really did not show any such abnormal patterns for sure.
Okay, fine. Okay, thank you.
Yeah. This is Samson, Director NATPAC.
Hello, sir.
Yeah, it was a nice presentation. Thank you for the presentation. Yeah, I just wanted to continue the concept which you presented, and then Anishkini as well as Vasudevan and our Praveen shared. See, the truck probably, let's say now you'll have a multiple the goods will be there in the same truck. Like whether you'll be in a position to accommodate that one. I'm just sharing that one in, from the Indian context. Like you cannot expect that the same material goods will be there in the same truck. You have a multiple, and with multiple destinations also will be there in that one. Okay.
Yes.
How you will handle such a situation in your
So I think the main thing to consider, or the reason that we opted for even a 0.25 mile buffer, is assuming that there is a large truck that will come and that will exit the freeway, and possibly there is a distribution center or whatever the warehouse that it is like that it delivers is located within this particular distance, and we know we assume that it is under 0.25 mile or 0.5 mile. So accounting for that particular aspect, so that was also one of the inspiration or reason that we chose this buffer. I think if we want to consider the one with multiple stops, and I'm pretty sure there is no way that one truck or every truck that is going into one distribution center may drop off all of the luggage. I'm assuming there are some trucks that do have multiple stops. So in case of Indian context, I think if we know any like proximity from freeway, that would be a very good resource to understand and explore that and capture the spatial characteristics, because ultimately no matter how many like functional class or interstates or even understanding getting the AADT, it also matters how effectively we can capture the spatial aspects or distance to the distribution center, or accounting for this distance is little important.
Yeah. Thank you for that. Like, you have used that the concept of the passenger, the travel demand estimation. I think you have approached that problem in the similar line, including the land use, employment, then population, and all those the concepts you have introduced there. Now, do you feel that whatever the passenger demand, the prediction or the estimation model is applicable, it is valid even in the case of goods also?
Yes, definitely. I would actually like to add one more thing. I mean, one from my own work related thing that I do. So I currently work for a metropolitan planning organization. So I don't currently work with directly the planning, but we work on the household travel surveys and supply the data. So that's where they input that data into the regional travel demand planning model. And then they input the land use and then population and estimate the travel times. But that obviously is applicable. For example, there was we used to have, I mean, that was not done in the recent times, but we used to also have commercial surveys where truckers were interviewed or what goods they were getting and what is the destination, and which is similar to the travel surveys. But the whole idea behind this particular research was, of course, like whatever is applicable to passenger is also remotely applicable to trucks, but in a very modified way, because passengers also almost like it all deals with how households are producing trips. But in this case, it is how the distribution centers and commercial areas. But of course, like the whole idea behind this research was to understand how economically we can do, because household travel survey itself is a very expensive effort to get the data, and even imagine I can't even imagine for a commercial, because it needs much more outreach and even the trust from people to respond to some surveys. So I think this research was mainly just to account for some data, that probe data that we get from many licenses that we already have, and to explore in a very economical way, and also understand some relationships that can be captured through the data.
Yeah,
I hope I did.
Yeah, that is correct. Like, listen, again, now, of course, that, and I have one more point, a point. See, this is the truck operation, or the, like, as you rightly mentioned, that some economic part is also attached to this one. Maybe in terms of the time, or maybe the the location, and how fast you are delivering the goods. Secondly, utilization of the truck. That is something like a multi-graded additive problem. How to increase that productivity of the truck and to get the maximum profit out of that one? Like how we can do that, or how we can convert your idea into that aspect, economic part.
So I think one practice that is kind of used in a very opposite way in the freeways that I travel here personally is to see if there is any heavy vehicle traveling. They suggest to go on a slower lane, because I mean, that is obviously disrupting the mainline traffic and everything. But I feel given this particular economic impact, either we can have some prioritized lanes for them, because in that way you're not interacting with the passenger cars or even mixed traffic streams. And also it makes their travel a little easier, because interaction between truck and truck, they know for sure that I mean, they have the safe gap and everything. So I think that's one of the mechanisms or techniques that can be explored, but I know there are always limitations of availability of land and also the traffic problems. For example, the place where I live, it has a huge traffic issue. Like, there are so many unreliable roads, and we have high occupancy vehicle lanes, but still it still has a lot of, even though there are a lot of incentives or everything provided, there's always a problem of congestion. But I hope in an ideal world, or even in the future, if trucks get some priority in any, or not in all areas, I would say in any areas that is needed. For example, if there is a hub or any distribution center where there is a huge traffic or huge loads or deliveries expected. So even in, at least in that, some small sections where the bottlenecks can be avoided, that can be like a really good practice, and that can solve a lot of issues. So this need not be like a whole, like some 100 miles of building some exclusive lanes. Maybe it may be just 2 miles, but still it can be helpful to reduce that congestion.
Thank you, Dr. Sarvani. Thank you, and
Thank you, sir.
convey my regards to your guide.
Definitely,
Okay.
sir. Thank you so much. It's really honorable for me, like, to present here.
Thank you so much.
Thank you.
Thank you, ma'am. Now I request Srimati Ardra S. Krishna, Junior Scientist, to propose the vote of thanks.
We have been privileged to gain deep insights into the topic, right condition and framework, understanding the truck traffic through the socio-spatial structure, delivered by our distinguished speaker, Dr. Sarvani Duvori. Your expertise has not only enhanced our understanding, but has also motivated us to understand the relationship between the truck travel time performance characteristics with the on-network characteristics and the land use characteristics. The way you outlined the research methodology and explained the truck travel estimation models was particularly valuable. We truly appreciate the time and effort you put into preparing and delivering such an engaging talk. We would also like to extend our thanks to all the attendees for your active participation. Your engagement has been in this event even more valuable and created an atmosphere of collaborative learning. We hope that you found the information presented today both informative and inspiring. We are very much thankful to our director, Professor Samson Matthew, sir, for his constant guidance and support in shaping this wonderful event. As we depart, let us carry forward the knowledge gained and the connections made. May the insights shared today fuel our curiosity and drive for excellence in the field of transportation. Once again, I would like to express our sincere thanks to Dr. Sarvani Duvori, the NATPAC team, and all of you for making this technical talk a great success. We look forward to more such enlightening sessions in the future. Thank you and have a wonderful day.
Thank you, Sarvani.
Thank you.
Thank you, sir. Thank you. Thank you, everyone.